Securing DHCP servers. The Dynamic Host Configuration Protocol, or DHCP servers as they're better known, are used to automatically provide client computers and other devices on your network with an IP address. Firstly, if you have the available hardware, you really should dedicate an entire server to running DHCP, since DHCP is a critical role, and like with most critical roles, perhaps with the exception of DNS and the Active Directory Domain Services role, critical server roles should always be on their own server. However, if available hardware is a concern, then installing additional roles such as WINS is okay, but definitely try to avoid things like DNS and Active Directory Domain Services roles from being installed on the same server as your DHCP services. Now, Windows 2008 also supports running DHCP on a server core installation, which is more secure since only the required services will be running on that server, and therefore the attack surface of the server is reduced. So if you are able to run with a dedicated server, then consider making it a server core build for greater security. Windows Server 2008 also supports handling our IPv6 addresses using a stateless configuration, which means that you can actually use this protocol without a DHCP server, and this works by using the MAC address of a network adapter as part of the overall address to prevent duplicate addresses. However, by having a DHCP server, you have the advantage of being able to configure additional DHCP server options, including the ability to use stateful configuration. Since IPv6 has many more addresses than IPv4 and can allocate them randomly over a larger address range, it also makes guessing IPv6 network addresses less likely. So if you're able to use IPv6, then that should be something that you should consider. Now, we should also actively monitor our network for rogue DHCP servers. So what's a rogue DHCP server anyway? Well, it's a server that somehow gets onto your network without it being authorized to be there. Now, this used to be a problem, many times not for malicious reasons back in earlier versions of Windows Server, but since Windows Server 2003, we've then had to authorize DHCP servers to work in an Active Directory environment. Now, often these rogue DHCP servers were installed into your network by accident, usually by someone installing it on a lab machine or perhaps on a user's desktop using a virtual machine so that they could play around with it and learn a bit more about it. The problem was that these unauthorized DHCP servers could start issuing out DHCP addresses by themselves, addresses which might be in use from one of your real servers. Okay, well, I've just installed a DHCP server on my network here on a machine with an IP address of 10.32.0.4, and I've just switched over to a separate machine, one that's running Windows Server 2003. Now, the reason why I've switched over to a Windows 2003 machine is that one of the tools that we can use to detect rogue DHCP servers is a tool called DHCP Loc, or DHCP Locator if you like, and this tool is part of the support tools that comes on the Windows 2003 CD. Now, unfortunately, there aren't any support tools for Windows 2008 yet, and since this tool doesn't work on Windows 2008, that's why I'm running it on Windows 2003. So we'll go and click on Start, we'll go to All Programs, Windows Support Tools, and we'll fire up the command prompt, and then we'll type in DHCP Loc, and followed by the IP address of this machine, which is 10.32.0.8, and we'll hit Enter, and now I'll press the D key on my keyboard, and this is going to attempt to discover a DHCP server on my network by sending out a DHCP request. Okay, well, as you can see, it's come back and it's discovered our DHCP server that I installed a moment ago, this server here, 10.32.0.4. And if I hold down D on my keyboard for a few seconds, you can see it's definitely the only server that we have that's responding, and it's sending back an offer of the IP address of 10.32.0.20. But on the right here, you'll notice that we have all these asterisks. If you see asterisks here, then this means that the DHCP server that's responding isn't authorized in Active Directory. So this could be a rogue DHCP server here that you might need to go and investigate. Now, in my case, it's just my DHCP server that I recently installed, but I purposely didn't activate it. Now, I will also point out that you shouldn't run this DHCP Loc command from a DHCP server itself, since DHCP Loc listens for DHCP servers by taking DHCP packets off the stack. So if you run it on a DHCP server, it's going to prevent DHCP packets from reaching the DHCP server service, so the DHCP server won't appear to respond. So make sure that you run this command from another machine that's not a DHCP server. So we know that we have a rogue DHCP server at this stage since it's not authorized, so I've just switched over to the machine that's running DHCP. So we'll go and click on Start, we'll go to Administrative Tools, and we'll launch the DHCP console. Now we'll go and right-click on DHCP at the top, and we'll choose to Manage Authorized Servers. And you will note that even though we installed DHCP properly, by default our server isn't authorized, so we'll click on the Authorize button, and then we'll enter in the name or the IP address of the DHCP server that we want to organize, and the host name of that is SO3, so we'll type that in and click OK. And it successfully resolved that, so we'll click on OK. And now our DHCP server is authorized. So if we go and click on Start, Administrative Tools, and we'll launch the Event Viewer, and on the left we'll expand Windows Logs, and we'll choose the System Log. And at the top here, we should see a DHCP server event with the ID of 1044, and that's going to indicate that we have an authorized DHCP server. But if you see any events with the ID of 1046, they're unauthorized DHCP servers, and we could also set up an event forwarding rule. So if we get any of these, we can notify someone, or if you're using a monitoring tool like MOM, Microsoft Operations Manager, you could look for them and then respond accordingly. Now, the next thing that we can do to further lock down our DHCP server is to configure reservations and exclusions. So in our DHCP server console here, if we expand our server, and then we'll expand IPv4, and then we'll expand our scope, if we select reservations, you'll notice that we currently don't have any reservations defined. So we'll right-click and we'll choose to create a new reservation, and we'll give this reservation a name, which I'm just simply going to call DCO1. And then we'll enter in the IP address that we want to reserve for DCO1, which will be 10.32.0.2. And then next we'll need to enter in the MAC address for DCO1. Now, a MAC address is simply a unique 12-digit hexadecimal hardware address that identifies our network card. But unlike IP addresses, it's something that's built into the network card itself and normally can't be changed. I say normally as there are some situations where you can actually configure your own MAC address, such as if you're building a virtual machine. Often those sorts of programs will let you specify your own MAC address, but in the vast majority of cases, the MAC address will be whatever it is burned into the network card itself. So if it's the MAC address of the machine that we're on right now, and you want to find that out, we can go and click on Start, and we'll open up a command prompt. And if we type in ipconfig/all and hit enter, and then if we scroll up, you can see the MAC address listed here. But to get the MAC address of a different machine, which is most likely what you'll need to do, we can simply ping the target host first. So let's just ping my domain controller here, which is DCO1, and we'll hit enter. And we can see it responded fine. We can tell that the IP address here is 10.32.0.2. So now we're going to type in ARP with the -G switch, and we'll hit enter. And we're going to look for the IP address of 10.32.0.2, and right here we can see the MAC address for DCO1. So we'll right click here and we will go and copy this to our clipboard by hitting enter. And now we'll go back to our DHCP console and we'll right click and we'll paste that in. And next we can enter in a description for this reservation, and of course I'd recommend you do that in a production environment, but here in our lab that's fine. And finally down the bottom we can choose if this will be supporting DHCP only or boot P as well. So we'll leave the default and we'll click add and then close. And now we've reserved the address of 10.32.0.2 for our host DCO1. So that means that even if our scope here did include this IP address, it won't be allocating this address for any other host since we've now reserved it for DCO1. Now, the other thing that we can do is exclude IP addresses from the scope altogether. So if we right-click on Address Pool and choose New Exclusion Range, we could either enter in a single IP address or an IP address range that would like to be excluded from handing out. So to exclude the IP address of 10.32.0.3 for argument's sake from being handed out, we could just enter it in here and then click Add. Or if it's a range of IP addresses, we could enter in 10.32.0.5, and then once we click Add, then the IP address .3, .4, and .5 will no longer be handed out. So the main difference between reserving an IP address and excluding one is that when we use reservations, DHCP will still be handing out the IP address to a host, but it's always going to hand out the same IP address to the same host, like we saw with DC01. It's still going to get an address from DHCP, but it will always be 10.32.0.2. So reservations should be used for DHCP-enabled devices that need to always have the same IP address. For example, you might have an application that's licensed to only accept connections from specific IP addresses, so certain clients might need to be always assigned the same IP address for that application to work. So a reservation would address this problem. Now conversely, when we exclude an IP address, DHCP will never hand out that IP address at all. So excluding IP addresses is best when you have servers like DNS servers and domain controllers that should have static IP addresses. So the point of this exercise is to ensure that access to your services in your network aren't interrupted due to someone else taking the IP address of, say, your database server due to a conflict and preventing your staff from accessing the database, and a well-thought-out DHCP server configuration will prevent this from happening. Now, another thing that we can do to improve security on our DHCP server is to configure network access protection. With network access protection, or NAP active, we can configure something called DHCP enforcement, which essentially means that a client that wants to use DHCP must meet certain system health requirements in order to obtain an unlimited IPv address lease. Now, when I say unlimited, I don't mean that the DHCP lease never ends. What I mean is that the client that gets an IP address from the DHCP server is allowed to access anything on the network if it meets these health requirements. If a client doesn't pass the required health checks, then you can force it to only access a more restricted part of your network. So it's kind of a way of saying that the healthy clients can go anywhere, and the ones that might be a security risk are only limited in what they can do. Now, these system health checks, by the way, are referred to as system health validators, or SHVs, that check to see if client computers that want to use our DHCP server have a firewall installed and enabled. They need to have antivirus and anti-spyware software installed, running and updated, and they also need to have Microsoft Update services enabled as well. Now, I will point out ahead of time that an in-depth discussion of network access protection is certainly going to require an entire video by itself, so we won't be covering it in great detail here, but we will cover the basics of what you need to know from DHCP security's perspective. So we'll close this and we'll go and open up our server manager by clicking on this little icon here next to the start bar, and then we'll select roles, and on the right hand side we'll click on add roles. Now we'll click next, and then we'll select network policy and access services, and we'll click next again, and we'll just get some information here about network policy and access services, which you can read if you like, but for now we'll click next. Now you can see here that there's a few different options we can install, but at this time we're only interested in the top one for network policy server, so we'll select that and we'll click next, and then we'll click install. Now this is going to take a few moments to install, so I will pause the video here and we'll return shortly. Alright, it's done, so we'll go and click close, and now we'll click on start, we'll go to administrative tools, and we'll launch the network policy server console. And in the middle here, we're going to click on the Configure NAP hyperlink. Now from the drop-down list here, we're going to choose DHCP, and we'll click Next. Now here we can specify NAP enforcement servers that are running DHCP, which are actually Radius clients, but since this server is a DHCP server that we're running this wizard on, we don't need to select anything here, we'll just click Next. We can also specify DHCP scopes if we like, but for an initial deployment, it's not required, so again, we'll click Next. Now we can configure user groups and machine groups that are going to enforce this policy, and in a production environment, you'll probably either have a group of users or a group of computers that you want to use to enforce this policy. So to add them in, you'll click on the Add Machine button, and then we can either enter in the name of a group here, or we can click the Advanced button and then Find Now, and then locate the group that we want to enforce this policy. Now, since I don't really need to apply this policy right now, I'm just going to cancel this, and we can add in groups later, so we'll just click Next, and then we can specify a remediation server group, which is simply a server or a group of servers that can provide software updates to our clients. So we'll ignore this for now, we'll just click Next. And finally, we can define a NAP health policy, and here the Windows Security Health Validator is already checked, so there's nothing that we need to configure here. We're also going to try and automatically update client computers with the latest software if they happen to fail our health policy. And at the bottom, the default behavior is to deny full network access to clients that are NAP ineligible, meaning they've failed our health policy. Or we could allow them full access, which kind of defeats the point of running through all of this in the first place. So I'll leave the defaults as they are. We'll click Next, and we'll get our summary of our wizard here, so we'll click Finish. All right, now if we come up to the left and we expand Network Access Protection, and we select System Health Validators, in the middle, here's the Windows Security Health Validator that we configured in the previous wizard. So we'll right-click on it, and we'll choose Properties, followed by the Configure button, and here we're able to define what conditions must be present on our client in order for them to have full access to the network. So we've got two tabs here, Windows Vista and Windows XP. So for Vista, they'll need to have a firewall to be enabled, antivirus and anti-spyware protection will need to be installed, running, and updated, and they'll also need to have automatic updating enabled as well. Now, we could optionally restrict our clients when they don't have certain security updates available as well, and that'll be anywhere from low to critical updates. Now, do also note that this does default to Windows Update, but I'd wager that if you're going through all the hard work of setting this up, then you probably have a Windows Software Update Services server in your company, in which case you're probably going to want to choose that. Now, on the XP tab, we've got pretty much the same options that we did for Vista, except that we're not checking for anti-spyware software. Now, once you've set up your policy and configured the client requirements, we'll go back to our DHCP server console, and we'll right-click on our scope, and we'll choose Properties, and then the Network Access Protection tab, and then we'll enable this scope and click on OK. The next step in our NAP configuration is a trip back to group policy, and this is a client policy that should be targeting your Vista and XP computers. So since at this point on my server I don't have a specific OU for my users or client computers, let's go and create one quickly. So we'll go and open up our Active Directory Users and Computers console, and I'm going to create a new OU, and we'll call this OU NAP Clients, and then we'll click on OK. And now we'll go and open up the Group Policy Management console. We'll expand our forest and then domains and then our domain. And now we'll right click on our NAP Clients OU, and we'll choose to create a GPO in this domain and link it here. Now I'm going to call this one NAP Client Settings. And then we'll click on OK. And then we'll expand our OU, and we'll right click on our group policy object and choose Edit. So under the computer configuration heading, we'll expand policies, then we'll expand Windows settings, and then security settings, and then we'll choose system services. And in the right hand side, we'll scroll down, and we'll need to locate the network access protection agent, and we'll right click on it, and we'll choose properties, and then we'll choose to define this policy setting, and we'll set it to automatic, and then click on OK. Now a bit further down here on the left hand side of our console, we'll expand the Network Access Protection folder and NAP Client Configuration, and we'll select Enforcement Clients, and in the right hand side, we'll right-click on the top option here, DHCP Quarantine Enforcement Client, and then we'll choose to enable it. Then we'll come down here and we'll right-click on NAP Client Configuration, and then we'll choose Apply. Now we'll go and expand our Administrative Templates folder, followed by Windows Components, and we'll select Security Center. And in the right-hand side, we'll right-click on Turn on Security Center, and we'll choose Properties, and we'll set this to Enabled, and then we'll click on OK. Now the next step will be to configure a security filter so that only our clients apply our NAP settings and not our servers. So we'll need to ensure that we have our NAP client settings policy selected in the Group Policy Management console, and in the right-hand side here under Security Filtering, we'll need to select Authenticated Users and we'll click Remove, and then we'll click Add, Advanced, Find Now, and we'll scroll down and we'll select a group that we do want this policy applying to, and ahead of time I went and created a group called NAP Client Computers, so we'll select that group, we'll click OK, and OK again, and now you'll need to ensure that the clients that you want to apply this NAP policy will have their computer accounts added to this group here, or whatever you've called your own group, or else they won't be applying the policy. The final thing we'll need to do before this all's working is to configure a remediation server. So I've switched back to my DHCP server and back in our Network Access Policy console, and on the left we'll expand Policies and we'll select Network Policies. Now in the right hand side we're going to double click on NAP DHCP Non-NAP Capable, and then we'll go up to the Settings tab and then click NAP Enforcement, and finally the Configure button. And then we'll click on the New Group button, and we'll type in Domain Services, and then we'll click Add, and we'll give this a friendly name of DCO1, which is my domain controller, and under the IP address or DNS name, we'll enter in DCO1 again, and we'll click Resolve, and that should come back as 10.32.0.2, which it does. So we'll click on OK, and OK again, and then OK one more time. All right, now we can close this window here. And now we'll double click on NAP DHCP Non-Compliant. Again, we're going to go to the Settings tab. We'll choose NAP Enforcement and go to the Configure button. And from the drop-down box here, we're going to choose Domain Services, and that's the group we just configured. We'll click OK, and then OK again. Okay, now I've just switched over to a Windows Vista client here that's configured to use our DHCP server. But first of all, I will point out that this client doesn't have antivirus software installed. Anti-spyware isn't up to date since it's a new installation which hasn't been updated yet. And to top it off, I've disabled Windows Update. The only real thing going for this machine right now is that I do have the firewall enabled. Now you'll notice right off the bat that this computer fails to meet our requirements of this network since we're missing several critical components required to pass a health check. Now, if we double click on this little icon here down in our system tray, it's going to pop up another dialog box that's going to tell us why we have a problem. So down the bottom here, we can see that Windows did not detect an antivirus program, and Windows Defender is also out of date. So we'll need to fix these issues on this client before we'll be granted full access to our network. So as you've seen, although it's a bit of a pain to set up, it's a pretty cool technology here which forces computers to remain up to date with the latest security fixes and definitions and patches in order to get a tick. Now, sure, I could go back to our Network Access Policy console and then uncheck the boxes that require me to use antivirus, anti-spyware, and use Windows Update, and this would all go away, and I'd get a different message telling me that everything was great. But who wants to dumb down their security like that? Security is supposed to be a challenge, and configuring NAP is definitely one of those challenges that some of you will enjoy, some of you are going to hate it, but overall, it'll definitely improve your security, forcing your client machines to comply with a good, sound security policy. Okay, well, let's move on to the final thing I want to discuss in this video, and that's giving consideration to which groups have access to your DHCP server. So I've switched over to our DHCP server, so if we go and click on Start, and we go to Administrative Tools, and we'll open up the Computer Management console, And on the left, we'll expand local users and groups and select groups. Now down here, you'll find two new groups. We have DHCP administrators and DHCP users. Now by default, neither of these two groups will have any users inside them. So the only reason I was authorized to configure DHCP is that I'm logged on using a domain administrator account. So rather than granting every person that needs to administer DHCP domain administrator rights, you can add accounts to manage DHCP into the DHCP administrators group. Now this is better since access to this group will give those people full administrative rights to DHCP, but not to the entire domain. The DHCP users group, on the other hand, allows those members to access the DHCP console, but they can't make any changes. Now, rather than making changes in here directly to these groups, and since anyone with permission can come in here and add people to the list, the recommended alternative is to use group policy. So I've just switched over to my domain controller here. So in our group policy management console, we'll locate our DHCP servers OU. And if you've built your OU structure in the way that we've already talked about in these videos, you'll probably have a DHCP OU here with a policy already being applied. Now, since I don't have a policy here yet, we're going to right click and choose to create a new GPO and link it here. I'm going to call this one DHCP users and we'll click on OK. And now we'll go and right click on our policy and we'll choose to edit it. And this will open up the Group Policy Management Editor. So under our computer configuration heading, we're going to expand policies and then Windows settings, security settings, and then we'll select restricted groups. Now, since this is a new group policy object, we obviously don't have any groups defined. So we're going to right click on restricted groups and then we'll choose add group. Now we'll enter in DHCP administrators and then we'll click on OK. Now in the members of section at the top of this window, we're going to click add and then we can type in the name of an account that we want to add to this group. Alternatively, we can click browse and then we can click advanced and find now, and then you can just simply locate the user that you wish to add. Now once you've added in the user and that user account will appear up here, what we have now is a restricted group scenario whereby it doesn't matter if I was to go over to my DHCP server locally and then add my account to the DHCP administrators group, I could add in 100 accounts for all that matters, since group policy, each time it refreshes, is going to take a look at the accounts that we've explicitly defined in here. And if you aren't in the group, you're going to be removed automatically. And in so many companies that I've worked with, I often don't see this feature being used, but it's a great option and it should be used wherever possible. Alright, well I've just switched back to our DHCP server, and the final thing we should do is configure auditing of DHCP events so that we can maintain a log of what's been going on with our DHCP server. Now, by default on Windows 2008, auditing will be enabled, and we can verify that by coming here into our DHCP console and then right-clicking on IPv4 and we'll choose Properties. And in the middle here, you can see that DHCP audit logging is enabled. And if we click on the Advanced tab, you can change the default path to where the DHCP logs are going to be saved. In this video, we've talked about practical steps you can take to make your DHCP server more secure. Firstly, if you make your DHCP server a dedicated server, and you should definitely do that for both security and performance reasons, and you should also consider making it a server core build as well. Then we talked about rogue DHCP servers and how they can be located so that you can remove them from your network. We moved on to talk about reservations and exclusions and how we can use them to ensure that a machine always gets the same IP address, and how to prevent other IP addresses from ever being handed out. We then saw how we can configure Network Access Protection, or NAP, so we can enable DHCP enforcement to force our clients to meet certain health requirements in order to obtain an unlimited IPv4 address lease. And finally, we've talked about the DHCP security groups and how we can use group policy restrictions to lock down who the administrators are for our DHCP servers. We hope you enjoyed this video and would like to thank you for supporting Winstructor.